So we're on problem number 28, which is just the next problem, like 25, except some slightly different numbers. So we're going to draw the figure. It's 28. Okay, make sure I do the right problem here. So we've got a horizontal line, got one that's slightly to the right of horizontal, and then we have another line that goes like that. Okay, let's group those together, make them into a triangle. Clone it. And then we're going to make it bigger in this case. Okay, so those are our two triangles. We know this is 12. This is 14. This angle is 1. This angle is 2 things, which means it matches up with this one and this one. So this is 14, this is 21, this is M. So the question is, what is M? Again, these two sides are similar because they're in the same orientation. We've got the angle up here and the angle down there, so those are the corresponding angles. So what we know is that we take 14 divided by 21, this ratio, 14 divided by 21, it's the same as 12 divided by M. So by the easiest thing to do is cross multiply. You get 14m is equal to 21 times 12, which is 21 times 12 is 252. And then we divide both sides by 14. Get 18. So this is 18. It's smaller, makes sense. So (31). In each diagram, there are two similar triangles. Find the unknown measurement in each. Hint: in the figure for exercise 29, the side length 100 is in the smaller triangle. Okay, so let's just draw this. Draw a triangle. I think I have a triangle that looks kind of like what we have here. So just take advantage of that. So that's one triangle. And basically what we're doing is this second triangle, which I didn't quite get in the right place there. But those two triangles are similar and they share this angle. So they have the same angle, theta here. And there's also 90 degrees. So since it's 90 degrees, that's 90 degrees. These two angles are also the same. And so you could separate those into two triangles if you wanted to. And actually, since I've already done that, why don't we do that? So here, so we really have two triangles now. And this one is theta, this one is 90 degrees, this one's the double. So now that we have this separated, what we can see is that, let me get rid of that little thing because that's, okay. So what we can say is, okay, so what are we given? Well, we're trying to figure out what C is. C is this big length here. So that's C. We know this is 100 because that's what the smaller triangle thing was. And then this part is, well, if we add these both together, we get 100 because we have 90 plus 10 is 100, and this one is 90 because that only goes to the first part. So we have these two ratios, so we can use that ratio here and project it to that ratio there. So what we have is basically 100, which is this length, to that length, which is 90, is equal to 100, which is this length, to that length, which is going to be greater than, it'll be like 110 something, but a little bit more than 110. So what we get is 90C is equal to 10,000. 100 times 100 is 10,000. So C is equal to 10,000 divided by 90. And so if we do that, 10,000 divided by 90 is 111. And then we have 0.111, which would be 1/9. So it's 111 and 1/9. That's the answer. Okay, 34. Solve each problem. A forest fire lookout tower casts a shadow 180 feet long. At the same time, the shadow of a 9-foot truck is 15 feet long. Find the height of the tower. So the way this works is we have some fire tower, which we'll just represent as a vertical thing, and we have a truck, and they're both sitting on the ground. So there's the ground. And because it's a shadow, it's going to cast a shadow depending on where the sun is. So we're going to put the sun up here. So there's the sun. And it casts a shadow, which goes like this. So here's the sun. So what we're basically doing is creating two similar triangles, just like we did in the previous example. Just need to make this a little bit longer so they meet up. And so what it says is the forest, okay, casts a shadow 80 feet. So this is the shadows down here. So this whole thing here is 80 feet. Well, let me think about this. Actually, they don't have to be in the same location. So let me, let's move this down here. So we do the same thing. So, okay, so then there's the truck, and there's the ground. Okay, now what's similar about these things is that we have 90-degree angle here, because it's a vertical thing, and we have this angle theta, and it's the same angle theta. That's where the sun comes in. The angle between the top of the thing that it shines over and the ground and the horizon is a constant. So since we have two angles the same, the third angle is also going to be the same, whatever that is. Because I would have all the angles equal, that means that we have a similar triangle. Okay, now so what do we know? 9-foot truck. So it's 9. This is 9. And the shadow is 15 feet. So in this case we have 180 feet. And so the question is, what's x? The height of the tower. So again, we just look at the ratios, and we have this ratio. So we have 180 over 15, which is the same, we're talking about the same similar part of the triangle, is x over 9. So we get 15x is equal to 9 times 180. And if we divide both sides by 15, we get 9 times 180 divided by 15. Stick that in our calculator. And so we have 9 times 180 divided by 15. And we get 108 feet. So 108 feet is this height. Okay, now see, you can measure, to get to the top of the tower it'd be hard to measure that. You have to, but on the ground you could pace that out, or you could use a tape measure. Here we probably could measure that as well. So we have 37. A house is 15 feet tall. Its shadow is 40 feet long. At the same time, the shadow of a nearby building is 300 feet long. Find the height of the building. So again, it's the same kind of deal. We're going to have these two triangles. So I'm going to make this the big one. I can shrink it down. So because it's a shadow, the angle is the same. So this angle, and it's a 90-degree angle here. So that's 90 degrees. this angle is theta. And let me make this into one object. Okay, we're going to shrink this thing down to pretty small because what it says is that this house is 15 feet tall and it casts a shadow 40 feet. Whereas the higher one casts a shadow 300 feet. And so the question is, what is x? So again, it's the same deal. We take 300 divided by 40 is equal to x divided by 15. So obviously this number is going to be less than 300. And it's probably going to, whatever this ratio is. So we solve for x, we'd get, well, we get 40x is equal to 300 times 15, or x is 300 times 15 divided by 40. So 15 divided by 40 is a fraction. It's less than 1. So we take 300 times 15 divided by 40 is 112.5. So that would be the height of the taller building. It also turns out you can also take the ratio of sides. Here we're taking ratios between sides, but you could also say that x over 300 is equal to 15 over 40. And if we multiply this out, you get 300. If you cross multiply it, you get 300 times 15, and then you divide by 40, and so you see we get the same expression. So it doesn't really matter how you determine that ratio as long as you are consistent. Okay, so the last one we'll do for this group 40. Find the unknown measurements. There are two similar triangles in each figure. Turns out these look like they are let's just say they look like isosceles triangles, but I'm really not sure if they have to be. So we have this triangle, and then all we do is we take a smaller chunk out here. So this is 6, this is 9, this is 12, this is K. So what is K? Well, the small triangle is this. So we have 9 to 6 in the small triangle. The big triangle is we add these two together. So instead of 12, it's going to be 21. 9 plus 12 is 21. And that is the ratio to the corresponding side. So 6 and K match up with 9 and then 21. So again, if we cross multiply, we get 9K is equal to 21 times 6. Or K is equal to 21 times 6 divided by 9, which will be 14. Why is that? Well, you can break 21 up in 3 ways. And then here you got like 2 to 3 is the ratio. If you divide both these by 3, you'll get 2 divided by 3. So 2/3 of 21 is 14. That's how it works if you don't want to use your calculator. Okay, so we'll stop there.